So let us start cubical expansion. So coefficient of cubical expansion of substance is defined as increase in volume per unit original volume per degree rise in the temperature keeping pressure constant. That is called cubical expansion. So basically it is increase in the volume per unit original volume per degree rise in temperature. That is called cubical expansion. So cubical expansion is related to volume. So its unit is per degree Celsius or per Kelvin. So it is denoted by gamma. So gamma will represent the cubical expansion coefficient. Let us understood it by example. Suppose V1 and V2 are the volume of solid at temperature T1 and T2 respectively. Then the coefficient of cubical expansion is given by. So gamma will be given by V2 minus V1 by V1 into T2 minus T1. So gamma unit will be, this unit will cancel with this. So unit will remain for only temperature now. So it is 1 upon T. So temperature unit is per degree Celsius or per Kelvin. So its unit will be only per degree Celsius or per Kelvin, right? So in this way we can understand the cubical expansion. So write this one. So this will be the
So I
formula
can't
for,
write.
okay. So this will be the formula for cubical expansion. So formula will be y equal to gamma equal to V2 minus V1 by V1 into T2 minus T1. So now we will study cubical expansion and linear expansion difference. So this is the difference between linear expansion and cubical expansion. First is linear expansion. It occurs in solid only. So linear expansion is shown by only solid particles, right? And cubical expansion is shown by solid, liquid and gas. So cubical expansion is applicable for all these three categories like solid, liquid and gases. But linear expansion is only applicable to solid particles. Now next point is increase in length on heating depends on original length of the substance, increase in the temperature, right? In linear expansion. Now look at the point for cubical expansion. It will depends on the original volume of the substance and increase in temperature also. So this is the main difference between linear expansion and cubical expansion. Look at the next point in difference between them. So I have told you already that linear expansion depends on original length and increase in temperature. Next point is nature of the material of the substance, right? Similar for the cubical expansion also. So cubical expansion depends on the original volume, increase in the temperature, nature of the substance. So these are the three main basic points on which linear expansion and cubical expansion depends, right? Now let us see the some points for the coefficient of cubical expansion. So gamma is basically called as uh, coefficient of cubical expansion. A way of picturing the expansion of object is to imagine when temperature rises you by looking at it through a magnifying glass. Okay? So it will appear slighter, bigger in all directions. So by using magnifying glass, you can see that increase in the volume of the object. So it will show in all the direction like length, breadth and height, right? So suppose this is a cube in which this is the length, this is the width and this is the height, in which all these three dimension is increased in little bit. So next point is a hollow ball expands in the same way as solid vessels of the same material, right? So read once, then I will move further. Now look at the next point. So your next point is expansion of different solids. Solids have the same dimension but composed of different material. So unequal expansion when heated through the same temperature range, right? It means that suppose an object made with the iron, another object is made with the copper and another made with the aluminum. So by heating with the same temperature, these different particles or metals, it will expand differently because its internal structure is different now, because these all three metals are having different atoms or internal structure is different. That's why it expands unequally when heated with the same temperature, right? Now to show that brass expands more than iron, a bimetal trip consists of brass and iron of the same length, either welded or riveted together so that on heating they do not slide away. Right? This one is brass and this one in iron. So this will show the transverse motion. This point is fixed, bottom point is fixed, and they are heated with the same temperature. Right? So on heating, the strip bends in such a way that brass is on the outside, iron is on the inside, right? This is because brass expand by greater amount when heated to the same rise of temperature, right? When they are heated with the same temperature, and brass will expand on the right outside and iron on the inside. On the similar manner, on cooling, the bimetallic strip bends in such a way that brass is on the inner side and iron on the outer side. This is because brass contracts by greater amount and length decreases by larger amount than that of the iron, right? So in comparison to iron, brass expands more on heating and as well as on cooling. So read once. So you can see at room temperature, brass and iron having same length, and when it is bended, so you can see that brass length is slightly increased when heated, and in the similar manner, it is contract more when it is cooled. So you can see the difference between the length. So this is the gap contracted by brass when it is cooled, and this is the part it is expanded as compared to the length of the iron. So application of thermal expansion of solid. So in fitting tires and gear rings, the metal tires on the wheel of locomotive are fitted by process known as shrinking on. The tire are heated by gas ring until the increase in their diameter enables them to pass over the wheel. When the tire cools, it grips the wheel tightly, right? So to fit the tire on the ring, it is firstly heated. Then when it is fitted, then it's allowed to cool down so that it grips the wheel and tires, right? So now look at the next point. Tire are heated by gas ring until the increase in their diameter enables them to pass over the wheel. When the tire cools, it grips the wheel and tightly. So this is your steel tire, right? And this is your wheel. So when we are putting this steel tire on the ring, that time it is heated, and when it is fitted here, then it is allowed to cool so that it is fitted there. Now look at the next process, that is riveting. Rivet is a small steel cylinder used to fix two metal plates tightly. So this is the process through which two metal is fitted tightly by this process. So hole is made in the metal plates of the joint. Rivet is chosen such that its length is slightly smaller than that of the plates. So length is slightly smaller than thickness of the plates. Okay? So rivet is then made red hot and inserted into the rivet hole. Then ends are bent over. At the rivet cools, it contracts and squeezes the plates together. Right. So when we want to join the two plates, so this part is inserted between these two holes. Okay. When it is hot and it is allowed to cool, then it will expand and will join this metal together. So this is the final product. after joining. So this is the first step, this one is second, and this is the final step when it is cooled. So this is the hot part when it is in the process. So that is called riveting. Riveting is nothing but it is the process to join the two metal strip. ठीक है, ये point आप लिख लो.
So I can't.
Now look at the thermostat switch. So thermostat is a device used to maintain a steady temperature. So thermostat is basically a device. It is used to maintain a steady temperature. Its working is based on the behavior of bimetric strip with the change of temperature. So it is based basically on the bimetric strip with the change of temperature. Initially, the electric circuit is completed as the points are in contact. So thermostat is basically based on the steady temperature. It based on the behavior of bimetric strip with the change of temperature. Initially, circuit is complete because two points are in contact. As the temperature of the room reaches the upper limit, bimetric strip bends away and the contact of the points breaks. Okay? And when it temperature exists its limit, bimetric strip bends away. The contact at the point breaks, hence the circuit also breaks. So at the upper point, its point breaks down. When temperature of the room falls below the lower limit, bimetric strip becomes a straight and the electric circuit is again completed. Right. So when the temperature falls down, bimetric strip becomes straight. In this way, its circuit is also completed. Right. That is called thermostat switch. Now look at the next point. Thermostat is used in electrical appliance. So like contact that completes the electric circuit. So this is a thermostat. This one is another metal. When it is connected to each other, then circuit is complete. So thermostat is based on the principle of unequal expansion of different solids of the same length when heated through the same temperature range. Right. When it is heated, when it is at room temperature, both length is same, and when it is heated, its length is increased, thermostat length. So on heating, the strip bends in such a way that contact that completes the circuit is broken. So when it is heated, that contact is broken due to unequal expansion of these two materials. This will expand unequal with this second one, right? That is called unequal breakage. Second one is on cooling, a strip bends in such a way that contact that completes the circuit, right, is re-established. So on cooling, metal bends in such a way that contact that completes the electric circuit is re-established also. Okay? So this is the main point. On heating and cooling, uh, com complete circuit is broken, right? On cooling, it re-established itself. Okay? So this is the main function of the thermostats. So basic point is when it is heated, contact will break down, and when it is cooled, it is again joined. That is called thermostats. And on heating, their expansion is different, right? On cooling, it regains its original length, both of the materials. So now look at the next point, advantage of thermal expansion. So first is virtually all common thermometer operate because some substance, usually a liquid, expands when it is heated. So all common thermometer operates when substance usually a liquid expands heated. So this is the main function of the or main advantage of the thermal expansion. Next advantage is a thermostat used in heater, geysers, ovens, and other such appliances operates on the principle of expansion. So basic parts of the most of the thermostat is a flexible strip made of two different metals. So it is used in the heater, geyser, ovens, and other appliances. Next point is a bimetallic strip which works on the principle of unequal expansion of different metal used in the balanced wheel and compensated pendulum. So bimetallic strip is also used in the unequal expansion of different metals, right? Like balanced wheel and compensated pendulum. So this is the three main advantage of thermal expansion. So read these ones, then I will explain the next point. On the other hand, I will also explain the drawback of thermal expansion. So a structure like railway lines and pipes, when subjected to large temperature change, tends to get its deformed, right? So railway track is made up of iron or some material. So when it is exposed to larger temperature difference, so it will deform its shape. So next point is some materials such as glassware breaks due to the strains which results from thermal expansion, right? So like when glassware is heated to the larger temperature, it breaks down, right? So this is the main drawback of thermal expansion. Next one is unequal expansion causes cracks in the wall of the building. So due to unequal expansion of the materials, like iron expands unequal with the aluminum, so due to this, wall of the building cracks during the summer vacation or summer season. So this is the drawback. Read this one, then I will explain next point. So your next point is fourth point, advantage of thermal expansion. Tremendous force exert when material expand or contract due to temperature change. Finds practical application in riveting fitting tires. So this is the main advantage. Tremendous force exert when material expands or contract due to temperature change. Finds practical application in riveting fitting tires. And and drawback of it is when water falls on a hot chimney, the portion where the water drops falls undergo contraction. So the remaining portion remain at higher temperature. So this unequal expansion leads to crack. So when water fall down on the chimney, so that part only contracts and the remaining point is still on the expansion form. So due to the temperature difference on the chimney uh, leads to crack. So it will crack down when it is cooled down, right? So this is the main drawback of thermal expansion. So read once, then I will explain next topic, thermal expansion of liquid. Now look at the next point, thermal expansion of liquid. A liquid has a definite volume, but it has no definite shape, right? So liquid having definite volume, but it doesn't take the definite shape. It doesn't have definite shape. So it takes the shape in which it is kept, right? So therefore only volume
Yes.
expansion is considered. So when liquid is heated in vessel, we do not usually take notice of the expansion of the vessel, right? So when we are heating the vessels, then that time all both expansion happens. Liquid expansion and expansion of the vessel also happen. So when expansion of vessel is neglected, when the expansion of the liquid is called apparent expansion, right? If the expansion of vessel is neglected, that time only we consider the liquid expansion, so that is called apparent expansion. Next point is when the expansion of vessel is taken into account, then the expansion of liquid is called real expansion, right? So when at a time of expansion, when we consider only the liquid part, that is called apparent expansion, and when we are considering the both, right, vessel expansion and liquid expansion, that is called really real expansion. So this is the main difference between them. So next point is experiment to demonstrate real and apparent expansion of liquid, right? So I will explain this one first. Read these 2 points, first and second.
Yes, so expansion.
Look at the next point, liquid expansion on heating. This is glass tube and this is your scale. Again, this is your flask and water bath is there. So expansion of the liquid, I will explain. So this is the scale. This is used for the measuring of the temperature and this is the glass tube, right? Which is put inside the flask and this is your water bath in which water is put here. So I will explain you.
Done.
Oh, good. Now look at the next procedure. So fill the flask with the colored water, right, up to the mark A. Hit the glass bulb as shown in the adjoining figure. The level will start fall to B due to the expansion of the vessel. Then the liquid began to expand and rise to point C. So you can see that this is colored water. Okay. So first the level will falls to B, right? Suppose we are filling the water up to A point and it will falls down up to B points, right? Then expands to rise C. So again it is rises to point C. So your BC represents the actual expansion of the liquid. If the expansion of the vessel AB is neglected as common the case, then the liquid expands from A to C. Then AC represents the apparent expansion of the liquid. So this is the main point. This is the apparent expansion, but actual expansion is BC. Right here written, it is written here. So your AC is apparent expansion and expansion of the solid is this one AB. So when actual expansion we are considering, that time it is only BC point will come down. So here I have written that BC is your real expansion, AC is apparent and AB is the apparent expansion. So when we are combining these two, AC plus AB, then we are getting the BC value, that is your called real expansion, right? So AC is the liquid expansion and AB is your vessel expansion. When we are considering both these expansion, then we are getting the expansion of the liquid with the vessel, right? So this is the procedure through which we can see that when we are heating the water in a flask, that time both expansion happen. Now look at the next point, expansion of different liquids. So this is your water, this is your ether, this is your benzene. So boiling water, this is your alcohol. So different liquids have different expansion, right? Because its internal structure is different now, that's right. So its expansion property is also different. So take a number of similar narrow neck graduated flasks and filled with the different liquids up to same level. Immerse them in a vessel containing boiling water as shown in the figure on the left hand side. It is found that after some time level of the liquid is different in different flasks, right? So this is the flask in which different liquids is filled and they are heated with the same temperature, but expansion is shown by them is different due to its internal structure, right? So this is the example for expansion of the liquid. So in this way it shows that different liquids expand differently. So write this point.
So I'll read.
Our next topic is anomalous behavior of expansion of water. How water expands differently with the different with or as compared to different liquids, right? So how it is different from the other liquids. So liquid expand when it is, but water so unusual behavior when it is experiment illustrates. So a flask is filled with the water, a thermometer and a long capillary tube are inserted through a cock in the neck. Flask is placed in ice, left for some hours to ensure that all the water is at 0 degrees Celsius. A piece of white paper is placed behind the capillary tube and the level of the water in the tube is marked. When all the ice has melted, the temperature of the water in the flask rises slowly and the position of the water index is marked as ir- irregular intervals, right? So this is the point. When all the ice has melted, the temperature of the water in the flask rises slowly. The position of the water index is marked as regular interval, right? So this is your capillary tube. This is your water level at temperature 0 degrees Celsius, water level at 4 degrees Celsius. So water level falls with the rise in temperature and rises with the fall in the temperature. So this is the behavior of water. So level falls when temperature rises, and when it is rises, temperature falls down. Okay. So when we are cooling the water, that time its expansion happens, and when liquid temperature falls down, right, that time its height will increase or its volume will increase. This is the behavior of the water. So write this point. So next point is, it is observed that temperature rise from 0 to 4 degrees Celsius, water contract and occupy the least volume at 4 degrees Celsius. And when it is cooled from 4 degrees Celsius to 0 degrees Celsius, water level is seen to rise, the indicating that water is expanding. So between 0 to 4, right, it shows the different behavior as compared to liquid show, right? So when it is temperature rises, it contracts, and when it is falling down, it expands. So this is the uh, analogous behavior of water. So read this one point, or I will explain next one also. The expansion of water, it is cooled from 4 degrees Celsius to 0 degrees Celsius, is called anomalous the expansion of water. And when water has its least volume and maximum density at 4 degrees Celsius, right? So now look at the next point, consequences of anomalous expansion. Fish and other aquatic animals and plant remain alive even when water bodies freezes. Suppose air temperature above the water is below 4 degrees Celsius. As the as the water on the surface cools down to 4 degrees Celsius, the volume decreases, density increases. Hence, it shrinks and displaces the warmer water to the surface when it cools down. Right? In this way, in this different behavior, fish and other aquatic animals keep himself or keep themselves alive whenever water is showing different behavior, right? 0 to 4 degrees Celsius. So write point fifth, sixth, and first point also.